Welcome to the 1406 workshop. Welcome to the experiment number 5 in Labflow, which is chemical reactions and equations. I will ask you to stop me at any time if my explanations are not clear or for any question. And also, I will stay after, when I stop the recording of this experiment, I will stay after to answer any other questions that you might have. So let's get started. The objective of today's experiment, chemical reactions and equation, is written at the beginning. The first and the main thing is to observe properties in chemical changes. So in the report, you will have 7 different chemical changes, and you will need to observe the chemical changes and write what are your observations. These are skills important for any scientist and also in general for everyday life. So this is an important, we will go over as I do each week. I will give you a quick overview of the experiment first, then we'll do a learning check to make sure the concepts are there, and then when you have to do the pre-lab quiz, you understand what is a chemical change and a chemical reaction and all the concepts that are around this main idea. And at the end, we will go over the report and make sure it's clear what you have to do in order to complete successfully this week's report. So as we said at the beginning, the main objective is to observe. Because you are not in the lab and we are doing this experiment virtual, the only way or this way, the way we are doing it here is by observing some pictures before the reaction, the chemical reaction took place, and after the reaction took place. And for 2 of the 7 reactions, you will need to have, you will need to look at a video and then write your observations. Also, you will have to identify when you are in the presence of a chemical reaction. And this experiment is all about chemical reaction. And also, balance the equation, you will be given the chemical reaction equation, so you will have to balance the equations. And also, to predict what type of chemical reaction is given. So we mainly, in this workshop, we are going to go over all these 4 objectives. The last one that says use the type of reaction to predict the reaction products is given. You will be given the balance equation. So you will observe the experiment and they will give you the equation. All you have to do is balance that equation. So the first thing that comes here in chemical is chemical changes. What is a chemical change? This is very important, especially obviously in chemistry. Last week, we saw in the previous workshop that physical changes change the appearance of a substance, but not the identity. Here is marked. Physical changes alter the appearance of a substance, but not this identity. What does it mean? They give us an example of the water. We boil water. and we see the vapor water. It looks different than the liquid water, but it's only a change in physical state. But what is the difference when we are in the presence of a chemical change? Because this week is the 7 experiments are chemical changes. So what is the main difference? Here it says a chemical change or reaction occurs when chemical substances transform into different substances with new properties. So this is what is important. They rearrange, the atoms rearrange to form a new substance with new properties. Then is when you are in the presence of a chemical change. If I ask you, and they give us the example, the common example of chemical change is the oxidation of iron into rust. Let's say you have a nail, an iron nail, and you leave it outdoor. You leave it outdoor and you come after a few days and the color changed, right? You see rust. We know that. And that is a chemical reaction. Why? Because the iron combines with oxygen to form an oxide, which is the rust. So let's balance this equation. We will go over that later, how to balance the equation. But so this is an example of a chemical change because this is the rust. It has obviously a different color. So this is just one example. So here they are giving you a table, table 1. It says signs of chemical reactions. This learn it because you will need to know when you are going to observe an experiment. You are not in the lab, but you are going to observe it here virtually. You have to look for signs. Here, signs of a chemical reaction. So you are looking, you mix, let's say you mix 2 liquids, and you see a change, and you say, it changes the appearance, right? Is this a chemical reaction or is this a physical reaction? So one way is to learn these 4 signs that if you observe one of these 4, you are in the presence of a chemical reaction. The number 1, evidence of a chemical reaction. Number 1, formation of a gas. When you see bubbles, you know that you mix 2 liquids and a gas was formed. That is one sign that you are in the presence of a chemical reaction. The second sign, formation of a solid, a precipitate. If you mix 2 liquids and you see that in your tube you have either it's not clear anymore, or you see a solid, then you are in the presence of a precipitate. You mix 2 liquids and now you have a solid. That is the second sign that this is a chemical reaction. So bubbles, solid. Number 3, changing color. Learn all these 4 because you are going to need it. If the color change, that's another sign. And the last one is the one that I like the least, but it is a sign. It says heat, loss, or gain. And they give you here examples. Yes, it's a sign of a chemical reaction. If you see heat, if the tube becomes hot, But remember that heat lost or gained is a sign that a chemical reaction might have happened. But we cannot say, remember this, that all reactions are accompanied of heat lost or gain. And they give you here the example of hydrochloric acid and sodium hydroxide. Hydrochloric acid reacts with sodium hydroxide, giving off heat and sodium chloride and water. When you mix an acid and a base, you obtain a salt plus water plus heat. So the only point, take it the heat with a grain of salt, which means that it is a sign, but it's not always. Not all chemical reactions will give off heat or gain heat. So this is basically the 4 signs that I would like you all to remember. Then they are talking about chemical equation. Let's go over what is a chemical equation. Well, we can describe a chemical change in different ways. We can describe if we are in the presence of a chemical change, we can say, as an example, for example, we can say, okay, I mix sodium metal with water, and the sodium reacts with liquid water to produce molecular hydrogen gas and sodium hydroxide. That's one way of describing a chemical change. But we don't want to. We want to make it simple. We don't want to use that many words. That's why we use chemical equations to represent a chemical reaction. And what is a chemical equation? We have in a chemical equation, we have different symbols. We use an arrow, this arrow, to separate the reactants from the products. So there are many symbols that we use to represent a chemical equations. To the left of the arrow, we always place the reactants. And to the right of the arrow, always we place the products. If we have only one product, we don't need to use this symbol here, that is a plus. We use this symbol only when we need to separate, when we have more than one reactant. So not all chemical equations are going to have a plus, only if we have more than one reactant or more than one product. What else we have in a chemical equation? We write the physical state of the reactants and the product in parentheses. So let's look here. Here they are giving us an example. Carbon, in parentheses, there is an S. S stands for solid. That it's an additional information about the physical state of the reactant and the product. So you know, when you mix a reactant, what is the physical state? And what else we use? Look at this little triangle on top of the arrow. That little triangle represents heat. That means that you mix the reactants that are on the left on the arrow, and you apply heat in order to obtain the product. Any questions so far? So let's continue then with the write-up of the experiment. So let's look here. They are giving you all the symbols, the plus that separates substance, what we just mentioned, the plus, the arrow that separates reactants and products. And we know now what is a chemical equation. But a chemical equation is not enough. We have to balance. Look at here. What does it mean to balance a chemical equation? You know that the atoms are not created nor destroyed. You studied that in the law of conservation of matter. That means that the number and types of reactant atoms must be equal to the number of types of products atom. So balance means that equal numbers of atoms for each element in the reaction on the reactant and on the product side. So here, what are they teaching us? What are they saying? All the reactants from the reactants are present somewhere in the products. So that's what we mentioned, and that is the law of conservation of matter. Now, how are we going to balance the equation? Remember always this: never use subscripts. Always use big coefficients to balance a chemical equation. If you use a coefficient, means that you are changing the formula of the compound. So I've seen this many times. Let's think. Let's write on the side. If I give you this reaction, nitrogen reacts with oxygen to produce nitrogen monoxide. And I ask you, can you balance this equation? How do you balance this equation? Some students won't count. Okay, on the reactant side, I count 2 nitrogens, and I count 2 nitrogens and 2 oxygens. And on the product side, I count 1 nitrogen and 1 oxygen. So many students come and say, okay, I need 2, and they use subscripts. This is a no-no. We cannot change the formula of any of the substances. All we have to do is write a big 2 in front of the nitrogen monoxide. So then we will balance the equation and we'll have the same number of atoms on the reactant side and on the product side. Any questions? Okay, they are giving us an example. For example, they are giving us this chemical equation. Hydrogen reacts with oxygen to produce water. How do we balance the equation? How? The first thing, it says start by evaluating what is present in the unbalanced equation. So what do I have on the These are the reactants before the arrow starts. So what do I have on the reactant side? Somebody can tell me. You can text me. What atoms do I have on the reactant side? What type of atoms I have on the reactant side? When you look at this reaction, what type of atoms do you have? You have hydrogen, right? What atoms do I have? I have hydrogen, and I have oxygen. How many hydrogens do I have? It says hydrogen gas. So that means hydrogen gas, each mole has 2 atoms. So on the reactant side, I have a 2 hydrogen. When I look at the oxygen, the same thing. 1 mole of oxygen gas has 2 atoms because I have this 2, this subscript 2, which means that 1 mole, the molecule has 2 atoms. So I have 2. Now tell me, on the product side, how many hydrogens do I have? You can send me a message. Count the number of hydrogens that I have on the product side. 2. How many oxygens I have on the product side? Just 1. Is the equation balanced? Sorry, 1. Is the equation balanced? The hydrogen is balanced, right? I have 2 on the reactant side, and I have 2 on the product side. The hydrogen is balanced, but the oxygen is not balanced because I have a 2 on the reactant side and I have a 1 on the product side. And remember, the only way to balance is using big coefficients. So that's why here comes the 2. If we add a 2 in front of the whole molecule, what happens? I have to arrange everything that changed. How many hydrogens do I have now if I add a big coefficient 2? 2 multiplied by the subscripts 2, I have 4. So I have to, once I add this coefficient, I have in the product side, I have to scratch this and say now I have 4. And how many oxygens I have? I have 2. Now I looked and I say, is this equation balanced? The oxygen is balanced, but the hydrogen is not balanced. Again, on the reactant side, I have a 2. On the product side, I have a 4. So what do I need to do? Look what they are doing. They add the green 2 in front of hydrogen. If they add this big coefficient 2, now I have 2 times 2, 4. So I correct in the reactant side, I scratch this and I say 4. And now I have 4 hydrogens on the reactant side before the arrow, and I have 4 hydrogens on the product side. 2 times 2, 4. And now I will check the oxygen. How many oxygens I have on the reactant side? 2. How many oxygens do I have on the product side? 2. This 2 is affecting the whole molecule. So if I have a subscript here in the hydrogen, means I have to multiply the big coefficient 2 by the little subscript 2. And then I have 4 hydrogens. But the oxygen doesn't have a subscript. So the yellow 2 will affect just 2 times 1, 2, and I have only 2 oxygens on the product side. And when I get to that point that I have the same type and an amount, equal number of atoms for each element in the reaction on the reactant and the product side, then I say, yes, this reaction is balanced. Any question? Okay, so then the last part of the write-up is types of chemical reactions. So once you learn to identify what to observe, to identify a chemical reaction, and the 4 signs of a chemical reaction, you have the equation, and you balance the equation. The last part is about what type of chemical reaction. You need to learn this, that there are different types of chemical reactions, and you will need to identify all these 5 different types of chemical reaction. It's not difficult. Let's go over each one. The first one in this table, it says synthesis or combination. How are you going to know when you see the balanced chemical equation? How are you going to know, okay, how do I know it's a combination? Combination are one of the easiest reactions to identify. Why? Because only one product is formed. So when you look at what is after the arrow, you see that is only one product. Okay, if you see that, 2 or more elements combine to form just a single product, you will say synthesis. The second type is decomposition. It's also very easy to recognize. When you learn this, you will look, it's basically the opposite of synthesis. What are you going to look at to recognize what type of reaction is this one? Well, if you see that on the reactant side, you have just one single product, one single substance, then you know this is a decomposition. It says a single complex reacts, a single complex reactant breaks apart into multiple simpler products. So you will have to look at how many substances you have on the reactant side. If you have just one, decomposition. So those 2 are easy to recognize. Single replacement is the next one. This is the one that the students have the most trouble recognizing. This is a redox reaction, which means that the elements change the oxidation state. But because you are not studying for now redox reaction, you will have to find a way of recognizing when is a single replacement reaction. And here the description that they give us, it says one element reactant replaces an element in a compound reactant. It's a little difficult to understand. So let's look at this in a different way. What do you have to look? What they mean with the description is, look at the chemical equation and you look at the reactants first, and you discover that one of the reactants is an element. What do I mean with an element? Just a single element that is in the periodic table. It's not combined. It's a free element because the magnesium is not bound to anything else, and you find magnesium in the periodic table. So it's one element, one free element from the periodic table. And then when you look on the other side, you found another free element, which is hydrogen gas. So one substance replaces another in the compound and creates a free element. So the way to recognize a single replacement is to look first on the reactant side and you see a free element, magnesium. And then you look on the other side and you see a different free element. Then you can think that might be a single replacement. In order to confirm, how do you do it? Basically, you look at why single replacement. Look at the hydrochloric acid here on the reactant side. The hydrogen is bound to the chloride, right? It's not free. But in the product side is free. And the magnesium that was free took the place of the hydrogen. That's why it's single replacement. The magnesium is replacing the hydrogen. And in the products, we have the magnesium chloride and the free element hydrogen. Any questions on single replacement? Let's go now to double replacement. Those are a little easier to recognize. Double replacement is basically changing partners, which means you have two substances and the silver in the reactant is bound to nitrate and is going to change a partner. Instead of being bound to the nitrate, it's going to be bound to the chloride. And the nitrate is going to be bound with the sodium. So basically, they are changing partners. So when you look at this reaction, you are saying, okay, silver nitrate. You have silver and you have nitrate. And then you have sodium plus chloride. So the silver doesn't want to be bound with the nitrate anymore. The silver is positive, doesn't have that many options. You know that opposite charges attract each other. So if silver doesn't want to be bound with nitrate, the only one that can be changed is chlorine. It's the only other that is negative. So that's why the silver needs to be bound. Silver has two options, either stay with nitrate or bond with chloride. And then, because this is a solid, this is the driving force of this reaction, because a precipitate is formed. You mix these two liquids and a precipitate is formed of sodium chloride, plus the nitrate is going to be bonded with sodium. And the last type of reaction that you are going to study is combustion. Combustions are very easy to recognize. Combustion is the reaction of hydrocarbons that combine with oxygen. So if you see that it's a fuel that combines with oxygen and the product is carbon dioxide and water, you are in the presence of a combustion. But sometimes, the majority of the time, the fuel is, in this case, we have methane, which is a hydrocarbon formed from carbon and hydrogen. But sometimes you have in the fuel has, for example, nitrogen. If it has nitrogen, you are also in the presence of oxygen. Instead of CO2, you can have NO2. It's not that common, but I wanted to tell you that the majority of the product is going to be CO2. But if you see a reaction that reacts with oxygen, it's a fuel, and the product is NO2, is also a combustion. Any questions before we go to look at some learning tech? So now we are going to do together some questions and then solve some questions together, and then we'll go over the report. I will need your help to tell me if the first reaction is balanced. Take your time, look at the first reaction. Magnesium reacts with sulfuric acid to produce magnesium sulfate and hydrogen gas. Is this equation balanced? What do you need to do in order to know if the equation is balanced? In this equation, you have a magnesium on the reactant side, you have hydrogen, and you have a sulfate ion. This is all you have: magnesium, hydrogen, and a sulfate. How many I have on the reactant side? One magnesium, two hydrogen, H2SO4, and one sulfate. And how many magnesium I have on the product side? I have one magnesium, one sulfate, and two hydrogens. When I have equal amount in the reactant and the product, I say the reaction is balanced. How about the second one? Is the second reaction balanced? First, I have to look at what type and how many atoms I have on the reactant side. So I have carbon, I have hydrogen, and I have oxygen. On the reactant side, how many carbons I have? 1. I have 4 hydrogen and 2 oxygens. And how many carbons I have on the product side? I go to the other side here and I say I have 1 carbon, I have 2 hydrogens, and I have how many oxygens? 2 here plus 1 here, right? So what do I need to do to balance the equation? The first thing I will do is to add a big coefficient 2 here. If I do that, I have to correct everything that is affected after the 2, which is the water. So I have to scratch on the product side. Hydrogen, I had 2, but now I added a big coefficient. So 2 times 2 is 4. And how many oxygens? This 2 in red is affecting the whole molecule. So I have 2 oxygens. And now I will look, is this equation balanced? Sorry, I said I have 2 oxygens here plus 2 here. So I had 4 oxygen. Forgot I had 3 and I said, how come? So if I add a 2 here, means I have 2 oxygens from the water plus 2 oxygens from the CO2. So I look at carbon and I said, yes, carbon is balanced. Very good. And then I looked at hydrogen and I say, yes, great, hydrogen is balanced. Now I look at oxygen and I said, is oxygen balanced? No, because I have 2 on the reactant side and I have 4 on the product side. But that's easy peasy. What do I need to do to fix that? Just add a number 2 here. And then I have the equation balanced. If I add a 2, everything is balanced. Any questions? Let's look at the next example. And the question, let's look at the example C, 1C. Okay. I think I got frozen. My computer got frozen. Give me a sec. Okay, I cannot write. Look at the, okay, now it's fixed. Okay. Is this equation balanced? Obviously no. Why? What do I have here? I have aluminum and I have oxygen. On the reactant side, how many aluminum? 1. How many oxygen? 3 times 2, 6. Okay, let's look at the product side. I have 4 aluminum and I have 6 oxygen. So what do I need to do? If I have 4 here, I need to have 4 here. aluminum. I have to put a big coefficient 4 there. And now the equation is balanced. Does it make sense? Okay, so what is the next question? What are the 4 common indicators that a chemical reaction has occurred? Who remembers? 1. Bubbles. Number 2, color changes. Number 3, precipitate being formed. Number 4, the change in temperature. We said that the change in temperature is a sign of a chemical reaction as well, because chemical reactions can release heat. But remember that not always the chemical reactions release heat. Let's look at the next question before we go to the report. Predict the products and write the balanced equation of hydrochloric acid reacting with magnesium metal. So if you have to do that in a quiz, how are you going to do? You are saying, okay, hydrochloric acid, you have to write hydrochloric acid, reacts with magnesium metal. And this, let me see, I think I got, give me a second. No, that's okay. I think it's a student that is trying to join. Okay, let's continue. Predict the products and write the balance equation of hydrochloric acid reacting with magnesium metal. So you will need to know how to write hydrochloric acid and magnesium and predict that the reaction will give you hydrogen gas and magnesium chloride. We use in parentheses, we can add the physical state if we want to make it complete. Is this equation balanced? What do I need to do to balance this equation? That's easy. If I add a 2 here, then the equation is balanced. What is the meaning of this symbol? If you look it up in the table, the symbol plus, and this one means that heat is applied. And the last question for you to remember is what symbols are always present in any chemical reaction equation? What symbols are always present? We need a reactant A that produces a product B. So we need at least one reactant, we need an arrow, and we need a product. This is the minimum. If we have more than one product, then we are going to say, okay, we use plus to separate them. But the minimum that are always present are at least one reactant, one arrow, and one product. For now, if you don't have more questions, I will share my screen of the Labflow and we will start looking at the report. Do you have any questions so far? Let me log in then into Labflow. Everybody can see the screen. Okay, so this is the report. When you get to this report in Labflow, you will have, as I said at the beginning, 7 different reactions that all you have to do is observe the reaction, write you are going to observe here, write the appearance of the reactants before the reaction and after the reaction. And then you will be asked to balance the equation to identify what type of reaction you have. This has to be one of the 5 that we went over. If it's a decomposition, if it's a combination, and depending on the reaction. So let's look just as an example at this video, just to guide you. What are you seeing? You have a metal. You look at the metal that is burning. Magnesium is burning and reacting with oxygen. So what else do you see? Before the reaction, you have the metal, right? You have a shiny silver metal, and then you burn it with the Bunsen burner, and you end up with what? A lot of light is released, right? And a new product is formed. So what is the evidence of the chemical reaction? Remember that we talked at the beginning at the evidence, if there is a change in color, if it's heat release. What do you think it is? And why do you see that white light? And it says, see white? Because when the magnesium is burning and it's very hot, what happens is that it's emitting all the visible wavelengths. That's what we are looking at it, and it's white. And it says that it can damage your eyes because it's also emitting some UV light. Any questions so far on how to complete this experiment? All you have to do is write here reactant appearance. So magnesium, the reactant is magnesium. What do you see? A shiny silver metal. What do you see? What is the evidence? You saw heat. What else? You saw. So you will write what your observation, balance. You are going to balance the way we balance. And what kind of reaction you think is this one? How many products you have? Okay, so I will let you think about it. How about the reaction of zinc and copper? This is the number 2. You are going to observe this picture, and you have the picture before the reaction and after the reaction. So I'm trying to guide you on how to complete this report. You are going to read everything. Here it says reaction of zinc and copper sulfate. So you will look at the picture before, at the first picture, and you will see, what do I see? I see the zinc, the metal zinc, that has a gray color, right? So you are going to write, okay, the zinc is gray or whatever, and then look at the solution. You are going to say, what color is the solution? The solution is clear, because clear means that you can see through. Doesn't mean that it has to have no color. So you can say it's a blue clear solution. And then you look at the next picture after the reaction. And you have to write what is the evidence, one of those four that shows that you are in the presence of a chemical reaction. Look at the color of the blue in the second picture. Is it the same color? No, the color fades. You see a change in color. What else you see? Look in the bottom. What do you see? Do you see a solid? Do you see a precipitate? So that is what you will have to do. Complete your observations, balance the equation, and write what type of reaction. What type of reaction you think is this one? Look at the reactants, you have a free element. And look in the product, you have a different free element. So you are going to decide what type of reaction is that one. Then the next reaction says reaction of metals and hydrochloric acid. They are giving you two pictures. What do you see in the first picture? Read everything, metals and hydrochloric acid. And here it says the images below show the result of adding magnesium and hydrochloric acid. What do you see? You see bubbles? What else you see? Take a look at the metal. Do you think that the metal do have the same amount in the first one or in the second one? Here looks like 1, 2, 3, 4. Looks like a little less. So you are going to write the evidence of the chemical reaction. You're going to balance the equation. It's pretty simple. And then the reaction of lead nitrate and potassium iodide. Read everything, because they just give you in this one only one picture. And it says the image below shows the result of adding colorless lead nitrate. So they are telling you the reactant, how it looks. Colorless lead nitrate to colorless potassium iodide solution. So they are basically, read all the details, because you will have to write the reactant appearance and the evidence. That is easy peasy. You mix two colorless solution and you end up with this tube. This is a sign of a chemical reaction. And look at the next one, the reaction of iron chloride and potassium thiocyanate. It's also telling you, you see that it says the image below shows the result of adding solution of iron chloride, which means that what the person has in his hand, the yellow, the clear yellow, is the iron chloride, and the colorless solution is the potassium thiocyanate. And then what happened when you mix that? That is a clear evidence of a chemical reaction. So that will be easy to complete. And the next one, you have a video. So you will see that this is a colorless solution that you are adding to a solid bicarbonate. And what do you see? Obviously, it's clear what you see. That's one of the signs of chemical reactions. So you are going to complete balance, and write what type of reaction. You don't have to predict the reaction because they are giving you the chemical equation. All you have to do is balanced. And the last one is hydrogen peroxide. So basically, they are showing you when they add a catalyst to hydrogen peroxide, what happens? What do you see there? Can somebody tell me, what do you see in that picture? What is the evidence of a chemical reaction in this one? Obviously, you see bubbles right there. And they also give you the chemical equation. So that is clear what you are going to write as an evidence of a chemical reaction. Any questions before I stop the recording? Then I'm going to stop the recording and I will stay in case you have questions. And thank you everybody for coming.